Hi friends, this is Sayed Reshma Sharif. Today we are going to discuss about microwave engineering topic waveguides. Okay, first of all, in waveguides, a frequency is higher than higher than 3 gigahertz. Here, for this 3 gigahertz, the electromagnetic waves along the transmission lines, these are all the transmission lines. Okay, here the electromagnetic waves, we are sending electromagnetic waves, isn't it? In these transmission lines or cables, it becomes very difficult, mainly due to the occurrence of both in a solid dielectric needed to support the conductor. In the conductor themselves, in these conductor themselves only, it must be a solid dielectric, a solid dielectric medium must be needed, okay, to support the frequencies to transmit. Okay, next, a metallic tube. This is a metallic tube which can be used to transmit electromagnetic waves with all frequencies. Whatever kind of frequencies, this metallic tube can be used for different frequencies. A hollow metallic tube of uniform cross section, the hollow metallic tube of uniform cross section, same cross section, but must be used transmitting waves, successive reflections from the inner walls. Successive reflections from inner walls, these transmission tubes must be used. Any shape of cross section of waveguides can support electromagnetic waves. But since irregular shapes are different to analyze, the rarely used rectangular, circular waveguides are become more common. Okay, here mainly we are going to discuss all this topic about waveguides and how for more number of frequencies how it must be needed. For different frequencies, a metallic tube is used. Usually electromagnetic waves use rectangular as well as circular waveguides. Commonly they are used. Now, how the propagation of waves in rectangular waveguides. Now, propagation. Propagation of waves in rectangular waveguides. Okay, now we are going to discuss in previously what we discussed, mainly rectangular as well as the square waveguides are used. Okay, here rectangular waves are situated in a rectangular coordinate system with its breadth on x-axis along with y-axis, and the wave is assumed to propagate along z direction. Let us see with a small diagram. This one is of x-axis, this one is of y-axis. Okay, a rectangular wave. Now I am taking a rectangular waveguide. Okay, a rectangular waveguide which is situated with both x and y-axis. Okay, whereas a waves that is propagate at z direction. Propagated at z direction. Okay, the distance between these 2 points is nothing but b, that is width. This one here at a point, this one is of its breadth. Okay, length into breadth, isn't it, in rectangle? Here this is air. This one is z, direction of propagation. Okay, this one is of rectangular waveguide which is located on both x and y axis. Here the B is a point, the width of distance between these two is B. Here breadth, the distance between this one is A. Okay, the air inside it. Z is the direction of propagation of a wave. Now the wave equation of transverse wave equation of both transverse electrical waves and transverse magnetic waves. The wave equation for this one is given by delta square Hz for transverse electric waves. Okay, transverse electric waves. Whereas delta square E is transverse electrical waves. Okay, transverse electrical waves. Now we are going to discuss a wave equation for these two. Now del square Hz is equal to minus omega square mu epsilon Hz. For transverse waves, transverse electrical waves, Ez is equal to 0. Whereas in transverse magnetic field, in transverse electrical field, Ez is equal to 0. Whereas del square Ez is equal to minus omega square mu epsilon Hz. For TM waves, Hz is equal to 0. Okay. Whereas epsilon is permittivity or availability of stored electrical energy in electrical field. Whereas mu is permeability that is 4 pi into 10 power of minus 7 n by a square. Okay, here now I am going to derive these two equations. Okay, let us see. For magnetic field, the electric field is 0. For electrical field, the magnetic field is 0. Now deriving the equation, and now exploding delta square del square Ez in rectangular coordinate. Okay, now here we are having all x-axis, y-axis and z-axis, isn't it? Now all our delta square Ez, it is in three forms. Okay, dou square Ex by dou x square plus dou square Ez by dou y square plus dou square z by dou z square is equal to minus omega square mu E is equation 1. Okay, this is of equation 1. Now I am equating this electrical field. Okay, for this electrical field in rectangular coordinate. This one is our equation. Now this equation is of 1. Now the wave propagation in z direction operates as in this z direction. In this z direction, the wave propagation, how? Z direction is dou square by dou z square is equal to r square, where r is nothing but here a constant. Okay, we have this r square in this z direction. We have to substitute this one in equation 1. Now dou square ex by dou x square plus dou square e by ez by dou y square plus dou square e by dou z square plus dou square dou by dou z of, it means we have to write r square into z term we have to write like this. Okay, is equal to this one minus omega square mu epsilon ez. Now we have to send all those terms here. What we will get? Now the equation is dou square ex by dou x square plus dou square ey by dou y square plus r square ez plus, I am sending all those terms here, omega square mu epsilon ez is equal to 0. Here in this both term ez is common. Now dou square ex by dou x square plus dou square ey by dou y square plus ez common r square plus omega square mu epsilon is equal to 0. This term is of constant. Okay, remember this equation 1, and this one is of equation 2. I am writing both equations here. I am erasing all those terms. Okay, let us see. This is of equation 1 and equation. This one is of r square plus omega square mu epsilon is of constant. Then r square plus omega square mu epsilon, that can be written as h square because this term is constant. Now I am substituting this term in this equation. Okay, what we will get? Let us see. Dou square ez by dou x square plus dou square ey by dou y square plus h square we are substituting in this term. What we will get? H square ez is equal to 0. Okay, now here h square ez is equal to 0 for TM waves, for transmitting transverse magnetic waves. Okay, here if we substitute Ez is equal to Hz, what we will get? We will get transverse electron. Here dou square Ex by dou x square plus dou square Ey by dou y square plus H square Ez is equal to 0, whereas this one here TM waves, whereas Hz is equal to 0. This term is equal to, this is for transmission of magnetic waves. Whereas dou square is similarly same equation we will get as a electrical field also. Dou square Ez by dou x square plus dou square Ey by dou y square plus H square Hz is equal to 0 for transverse electrical waves. Okay. By solving the above partial differentiation equation, we will get solution for Ez and Hz using Maxwell equation. By using Maxwell equation, let us discuss in next video. Thank you for your watching. If you have any doubts regarding this, please comment me on my comment section.